Similar shapes. So mathematically similar shapes are shapes that have the same angles. What that means is this angle here, 90 degrees that I've got, is corresponding to the 90 degrees on the second shape. This angle here, whatever it may be, that's also equal to this angle here. And then the final angle here that we have is equal to the final angle here. And so they all match the angles. And as such, we can then say that one shape is an enlargement of the other by a certain scale factor. Now the scale factor, we are going to be coming across three scale factors, and we're going to distinguish between each of them, and they are going to be length scale factor, area scale factor, and volume scale factor. So first of all, we're going to look at these two shapes, which are said to be mathematically similar, and we're going to establish how many times one is bigger than the other. So if I first of all find some corresponding lengths, so when I say corresponding lengths, I need to make sure my shapes are in the same orientation. So they are in the same orientation at the moment. If they're not, I would always redraw them so that they are in the same orientation. And then I can see here I've got 3 centimeters and 9 centimeters, which are corresponding sides. So from here, these are my lengths, 3 centimeter and 9 centimeter, as we've got measurements, units of centimeters, which are length. So we can figure out how you go from 3 to 9, and we can find out what the enlargement is. What is this scale factor? And then we can write down what this scale factor is. So to work out the scale factor, we can do the larger shape's length divided by the smaller shape's length. So if I do 9 divided by 3, this gets me the length scale factor. So 9 over 3, which is equal to 3. Okay, so I've got my length scale factor, and now I can go and find out the second length. So I've got 2 centimeters here. So to go from this length to that length, I can use my length scale factor, which is 3. So I can do 2 times 3. That gets me 6 centimeters. So I can figure out the second one's length. And so if I had another length, I could figure out the other length as well. Okay. So that's my length scale factor. Now that's one type of scale factor we looked at. Now I'm going to also look at the area of both of these shapes. So first of all, I'm going to actually work out the area of each of them using the measurements that I've got. So the triangle on the left, the blue triangle, 2 times 3, which is 6, divided by 2. My area here is 3 centimeters squared. Okay. Let me just write that down. Area is equal to 3 centimeters squared. Let's take a look at my second one. Its area is 9 times 6 divided by 2. So we've got there 27 centimeters squared. So I worked out the area by just doing base times height divided by 2. So now let's take a look at this. Now notice here that to go from one area to the second area, from one shape's area to the second shape's area, it's actually not timesing by the length scale factor, which we had. So if I times it by 3, you can see 3 times 3 is 9, so it doesn't get me the 27. So how do I get to the area scale factor? Well, I can find the area scale factor in a similar way. So I'll write down here area scale factor. I can do the larger one's area, so 27, divided by the smaller one's area, 3, which gets me 9. So I've got my area scale factor here. So there's my area scale factor, and that I would use with areas. We'll see later on in an example. I'm going to also introduce volume here. So I'm going to make this a 3D shape, a prism here. So I'm going to extend the length here, and I'm going to extend it by a length of, let's say, 1 centimeter here. Okay, so I've extended this prism. Likewise, I'm going to extend the other one. Now, if I've extended this by 1 centimeter, then the other one, if it's mathematically similar, has to extend by 3 centimeters, and that's because the length scale factor is 3, so I need to times it by 3. So here, this 1 centimeter is a length, so I need to apply the length scale factor. So to go from that length to the other length here, I need to then times by 3. So I'm just going to draw the other length here. I'll just make a note here. That's 1 centimeter. So to go from there to there, again, length scale factor times by 3. So this should be 3 centimeters. Now my shapes are 3D shapes, but they are mathematically similar. So I can work out the volume of both of these shapes by doing cross-section area times the length. So the volume of the first shape will be its cross-section, which is 3, times its depth, which is 1. So 3 times 1, which is 3 centimeters cubed. The volume of the second shape is going to be its cross-section, which is 27, times its depth, which is 3, 27 times 3. Okay, so 27 times 3, we get 81 here, 81 centimeter cubed. Now, just like we've figured out the length scale factor and the area scale factor, we can also work out what the volume scale factor here is by dividing the larger volume, so 81 centimeter cubed, divided by the smaller volume, which is 3. Okay, so if I do 81 divided by 3, that gets me 27. So there's my scale factor for the volume. So what that means is if I want to go from one volume to the other, I'd have to times by 27 using the volume scale factor. If I want to go from one area to the other, I'd have to times by 9, which is my area scale factor. And if I want to go from one length to the other, I'd have to times by 3, which is my length scale factor. So there I have my length, area and volume scale factors, which are the things that we are going to be asked questions on. Now, there is a link between the length, area and volume scale factor, which we should now be able to see. So if you look carefully at these numbers, we've got 3 here, we've got 9, we've got 27. Now there is a link, and we need to establish what this link is, because that will enable us to then work out the scale factors from just simply knowing one of the scale factors. So if I know the length scale factor, to go from length to area, I'll give you a little hint. It's to do with thinking about the units. So the units of length is centimeters here. The area is centimeter squared. And centimeter cubed is the volume unit. So to go from units of length to units of centimeter squared, you can see here we square. Okay, we square. So likewise, if I want to go from my length scale factor to my area scale factor, I would do 3 squared, which gets me to 9. So similarly, if I want to go from centimeters to centimeter cubed, I would cube my units. So likewise, if I want to go from length scale factor to my volume scale factor, I would do cube of that. So 3 cubed, which gets me 27. So that's another way we can find the scale factor. So if I know what my length scale factor is, suppose my length scale factor is, in this case, as it is 3, we would simply square it to get to the area scale factor, and we would cube it to get to the volume scale factor. Now, if I started off with my volume scale factor, then I can go from my volume scale factor and I can cube root to get to my length scale factor. And then I would square it to get to my area scale factor. So the idea is, if you want to work out all the scale factors and you're given area or volume, always start by finding out the length scale factor first by either square rooting the area scale factor or cube rooting the volume scale factor. And once you have the length scale factor, you can then get to any of the other scale factors by either squaring or either cubing. Okay, so let's look at the application of this to an exam style question. So here's we have a question involving mathematically similar shapes. The question starts off by saying the diagram shows 2 similar solids. So the word similar means that one is an enlargement of the other. Now, notice here we are given length 4 centimeters and length 8 centimeters. So the first thing which I'm going to do here is I'm going to work out what my length scale factor is. So I'm going to write down length scale factor is equal to 8 over 4, which is 2. So I've got my length scale factor. Now remember, I can work out my area scale factor without needing to use areas. I can simply use my length scale factor to get to each of my area scale factor and volume scale factor. How I do that is by squaring and then by cubing. So if I square the length scale factor, I get to 4, and if I cube it, I get to 8. So then I've found my area scale factor and my volume scale factor, which I'll use for the rest of the question. So it goes on to say solid A has a volume of 80 centimeter cubed. I'm going to put 80 centimeter cubed onto my diagram so I can see it's near solid A. And the first question is asking me to work out the volume of solid B. So I know that if I want to go from my smaller volume, the 80 centimeter cubed, to the larger volume, to this one's volume, I need to times it by the volume scale factor, which we have here, which is 8. So if I multiply by 8, I've got 80 times 8, which gives me 640 centimeter cubed. So there we have it. Our volume scale factor is 640 centimeter cubed. The unit's already written for us. Now, the second part of the question said solid B has a total surface area of 160 centimeters squared. So I'm going to just write down here for solid B, surface area is equal to 160 centimeters squared. Now, as this is an area, it's got units of area centimeters squared, we need to use the area scale factor if I want to work out the total surface area of solid A. So solid A, how do I go from the larger surface area to the smaller? Well, I'm going to use the scale factor, but since I'm going to the smaller one, I'm going to divide by that scale factor. So I'm going to do 160 and I'm going to divide that by the area scale factor since I'm working with areas here. The area scale factor is 4. So I'm going to divide 160 by 4 and that gets me 40 centimeters squared is the surface area of the first shape, shape A. So I can write down here 40 centimeters squared is the area, surface area of my shape A.